So most of you will probably remember that we were supposed to have an evening of cell phone photography, which got canceled on pretty short notice. But instead, Mark agreed to jump in for us, which is super grateful for. And I think you'll be really, really amazed by his presentation. I met Mark and saw his presentation in Pincher Creek at the Light Chasers Conference, and it was amazing. So his presentation tonight will be on the aurora, chasing the aurora and the science behind it. I think you'll find it very inspiring and informative, and got just really, really amazing images, and hopefully you will learn lots and get out this summer to chase the aurora. Mark is in Edmonton, and besides doing landscape and aurora and storm chasing, he also does some one-on-one sessions for Lightroom. So if that's something that you're interested in, you can also contact him about that. So I will turn it over to Mark. Enjoy the presentation. We'll do the questions after, and just probably with the microphone, just go around and let everybody ask their questions. All right, I'll turn it over to Mark.
Sounds good. Thanks, Carmen. All right, so thank you guys so much at CAPS Photo Club for having me out tonight. I wish I could have been there in person, but it just didn't work out with the travel. I had some local appointments in Edmonton this afternoon. But yeah, so my presentation this evening is called Nights of Wonder. And in this presentation, I'm going to go over some things I've learned over the last decade or so about chasing the Northern Lights, going over some of the science behind them and putting yourself in the best position to photograph them. If you've ever gone out, just randomly late at night looking for the Northern Lights, chances are likely you didn't see them. You may have seen them, but this presentation will hopefully put you in a position to actually kind of forecast a little bit ahead of time and learn to read some of the data that goes into the science behind them and gets you out to get them without being out there for a whole evening just kind of twiddling your thumbs and waiting for it to show up. And I just want to throw a little disclaimer out there. I'm not a scientist or anything like that. These are just some observations I've made and things that I've learned through trial and error about chasing the aurora. So hopefully there'll be some tips in here that'll help you chase it. All right, so just a little bit about me. As Karen mentioned, I'm a nature photography generalist. So that means I like to shoot pretty much anything in nature, whether it's landscapes, wildlife, abstracts, and intimate scenes in nature. But I'm especially fond of weather. So whether it's severe storms in the summer or the aurora, which is pretty much year-round in Alberta here, those are probably two of my most favorite categories or subjects. And I've had some chances to work with some really wonderful companies and brands across Canada, and even some specific Aurora related projects with the Globe and Mail and CBC Radio, and Northwest Territories Tourism. So I've been really fortunate and grateful for some of the opportunities I've had. And yeah, so chasing Aurora is one of my biggest passions. And it goes way back to the early 80s when I was just a young boy, about 10 years old. That's when I first saw the aurora and had my first experience with the aurora. So it was, my first memory was basically just on a back road. It was one of our family outings. I was going out with my parents to one of their friends living out on an acreage, out on a farm. And, we would be going down these quiet roads late at night, no light pollution or anything like that. And just seeing the aurora dancing through the back window of the car. There was no internet back then, so you couldn't really kind of just, hey, what is that kind of thing, and do some research on it. So I would go out to the local library and take out some books and learn as much as I could about the aurora and the northern lights and even the night sky. So that's basically how my passion for it was born. I was your typical 80s kid with a telescope looking up into the night sky with all these dreams of the stars and planets and that kind of thing. So yeah, and that's really where it all started for me for the aurora. So a little bit of things that we know about the aurora. So they're dependent on activity from our sun through sunspots, and I'll get into some of the other things, some solar flares and that kind of thing. But even though you can see them year round in central Alberta, you'll have a much better chance of seeing them during the winter months, and that's just simply due to longer hours of darkness. As we know, it's starting to get dark now, probably around 9:30. In the winter, it's getting dark around 5 o'clock. So we've just got way more darkness in the winter. So that gives you a better chance of seeing them. Having said that, though, you can see them year round in Alberta, just shorter windows during the summer evenings. And then the further north you go is generally the better, the stronger they're going to be. However, getting into the higher latitudes, even getting up to Fort McMurray here in Alberta, you're pretty much going to have perpetual daylight throughout the summer months. So typically from May to August, you won't see them the further north you go. However, here in Alberta, we will see them pretty much in central Alberta. You'll see them year round. Even in those summer months right around the solstice, June, July, there will be some windows to see them later on into the evenings. They do take a lot of dedication and perseverance. Like I said, some nights you're out there just waiting and waiting for them to hit. Even with the data that you have presented in front of you, sometimes it's kind of hit and miss, and you're still waiting on things. All right, so like I said, we're so lucky here in Alberta that the Northern Lights are visible year round. I've been fortunate to shoot them myself each and every month of the year. Like I said, it does take a lot of perseverance. For every time I've gone out for Northern Lights, I'd say I've come away with images I'm happy with probably 1 out of 4 times. There is a lot of nights where it is a dud, even though the data looks amazing and everything is lining up. But there's so many variables involved, and I'll get into all those variables when we get into the actual science and data behind it. But there's so many variables involved that even if just 1 or 2 of those variables doesn't pan out, then it's essentially just going to kill the whole show. So over the years, I've become maybe a little bit of an aurora snob. My thresholds for going out have kind of increased. I don't just want to see a little green glow on the horizon anymore. I want to see, aurora filling the skies. So I think as the more times you see them, you want to see them better and better. And, after a while, you're not that interested in just seeing a little glow on the horizon. But if you're going out for the first time, maybe it's great to see that and to practice on that before you get those big shows. So over this presentation, I'm going to offer some tips to help take some of the guesswork out of that, and hopefully, you can get out and be more hits than misses. So first of all, what causes the northern lights? So it's typically dependent on solar flares from our sun. So solar flares in the sun create events such as coronal mass ejections and coronal holes. So essentially, the sun sends electrons towards our planet, which react with the different gases in our atmosphere, like oxygen and nitrogen, causing the northern lights. So if you look at this little graphic here that I got from the NASA website, it's almost like a bit of a rubber band where you have all this tension that's catching with our magnetosphere, and then ultimately the tension snaps and reconnects, and then that sends all these particles towards our atmosphere. So our atmosphere actually protects us from the radiation in these particles, and then the magnetosphere draws in some of the particles, and then they'll react with our atmosphere and those different gases. So you'll see for oxygen, you'll see green at lower altitudes and red at higher altitudes, and then nitrogen for pinks and purples. So those two events that I mentioned, so coronal mass ejections is the first one here. So this is like almost like an explosion on the sun, like almost like a volcano exploding and then sending a whole bunch of gas towards our planet. So I find that these tend to hit hard and fast. Sometimes they'll pass within a day or even a half a day. So we might get, a coronal mass ejection. It takes about 3 days to get here from the sun. So depending on what time of day it gets here, it might get here at 8 o'clock in the morning and then have completely used up all of its energy by nighttime. So part of it is luck as well, when that's going to hit. And they can kind of narrow it down to about a plus minus 12-hour window. But ultimately, you want it to kind of hit just before it's starting to get dark, and that'll give you a great full night of aurora. So yeah, it seems like Europe always gets the great shows. Norway, Sweden, Finland, and those kind of places. So it's probably just bias and perspective from here, but it seems more often than not they get a lot better shows over there. So the second one is called coronal holes. So these are just kind of more steady and slow streams, just basically a hole on the surface of the sun that lets out all this gas. They're typically weaker than the coronal mass ejections in the previous slide, but these can cause northern lights for several days on end. So typically when you see periods of like northern lights of 2 or 3 nights in a row, these are generally caused by coronal holes. Another benefit to the coronal holes is they tend to return for another month or two when that existing hole and the sun rotates back into an Earth-facing view. It'll produce that coronal hole solar stream again as well, pretty much around the same time as the previous month. All right, so getting into solar cycle. So the solar cycle is sunspot activity, and it goes in peaks and valleys over an 11-year period, with a maximum during the middle of the period. So into that 5 or 6 years into that 11-year period. So we're currently in solar cycle 25 right now, and solar maximum of that cycle is slated to hit us in 2025. So from here on out to 2025, we're going to have a lot more sunspots and potentially a lot more nights of northern lights and solar or coronal mass ejections and solar streams and that kind of thing. And then once 2025 is passed, it'll slowly, gradually back down to about 2031. It'll kind of bottom out again, and we'll be in something called solar minimum, and then the next cycle will ramp up again. So where can the northern lights be seen? So typically there's something called the auroral oval that goes around the globe. The colored area will be the line of sight visibility. So typically countries closer to the poles, of course, have an advantage being in the cut line for viewing. So of course the hotspots can be Alaska, here in northern Canada, even into the northern US at times, the Scandinavian countries, Iceland, Greenland, Russia, and then of course you've got the southern lights that are commonly seen from places like, you can see those from New Zealand and Tasmania and the South Pole and Antarctica. So where do we get the data from? So the data comes from satellites that are basically orbiting between us and the sun. So it picks up all that data when a solar stream has sent to us. So there's a couple of satellites up there right now. ACE is the original satellite, but it was replaced by Discover satellite in 2015. ACE is still operational as a backup. It was used for approximately a year in 2019 to 20 when Discover was having an equipment issue. I'm not sure, but I think the lifespan on Discover is coming up pretty quickly as well. I think they're good for about 10 to 12 years. So I'm not sure what the plan is after that, if they're going to, just do some work on Discover to keep it going, or if they're going to put up a brand new satellite. Of course, every time, as technology evolves, we get more and more data and takes a lot more guesswork out of it. All right, so this is a screenshot of the app Space Weather Live. So that's my absolute go-to app for Northern Lights. I don't use any of the other ones. This one, it gives us all the real-time data we need. It's really reliable. It's not forecast, it's actual real-time data. So once you learn how to interpret this data, it takes a lot of guesswork on whether or not it's worth going out or not, right? Because, not many people want to just, go out on a weeknight when they have to work the next day and, end up sitting out there for Northern Lights for 3 or 4 hours and nothing happens, right? So there's an ongoing joke in the Aurora community that asks, is it worth putting on pants tonight? So, I personally, I hate putting my pants back on late at night. So I'd rather have some data thresholds that have to be met for me to consider even going out. So, and a lot of my friends call me an Aurora snob just for this reason. So it has to be like really good for me to even consider going out at this point. All right, so you might have heard something called the KP index. So like KP3 or KP5 when it comes to the strength of the northern lights. So it's something called the Kensington Planetary Index, and it's generally a forecast of how strong the northern lights might be. So this isn't anything to do with the Space Weather Live app. This is just like a long-term kind of forecast for the next couple of weeks or so. So once you get into the level 5, that's considered geomagnetic storming conditions. Up in Yellowknife, places like that, the high altitudes, Norway, you can get aurora at a 1 or even a 0. It's just you're so far north that it's almost constant. But here in central and southern Alberta, you probably need at least a 3 to see anything at all. And even then, it's just going to be kind of just a low band on the horizon, just kind of a low, yeah, just essentially that's what it is, a low band. Having said that, while the KP index is a great starting point, it's not the be all and end all. I've seen some displays that were stronger at KP4 than KP6 because of some of the other variables involved, like the solar wind speed and that kind of thing. So I'll get into that in the next couple slides here. All right, so first up is something called the hemispheric power. So this is an estimate of strength based on the measured protons and electrons in the upper atmosphere. Typically for me, I like to see around 40 gigawatts to consider worth going out. So this is a screenshot of a really strong display we had in November 4th, 2021. This had a hemispheric power of 190 gigawatts. So that produced some crazy, beautiful auroras, red auroras. We just had another show recently on March 23rd of this year as well. Unfortunately, I was a bit clouded over for that one, so I didn't really see it as good as a lot of people down in Calgary and down further in the southern part of the province. So hemispheric power is one of the actual strength of the aurora. And the next thing, which I find is really important, is something called the solar wind. So solar winds arrive from the sun, and that's typically that either the coronal mass ejection hitting us or the high-speed coronal stream from those coronal holes. So this will, of course, affect the displays of northern lights that we see. So the higher number, the better for the solar wind. The default speed without any extra influence from solar flares or coronal mass ejections or anything is just a typical default speed of about 300 kilometers per second. So I like to see probably around at least 500 kilometers per second before I decide to head out. And then the solar wind density measures the amount of particles in the density of that wind. So for that as well, the more the better. And then probably the most important ingredient for Northern Lights is something called the BZ. So you might have heard the BZ's got to go south. So this is essentially the magneticity of the solar particles being drawn into our atmosphere. So bringing them in, that creates a negative on the data scale. So it's highly unlikely you'll get Northern Lights with a positive BZ so that means it's going into the green. So think of it as opposite to a stoplight. So red means go, get out, there's going to be good aurora. Green means stop, hold off, there might not be aurora. So you really want the BZ to stay in the red for a sustained period of time, and that'll just charge all those particles up in the atmosphere and typically result in a really good display. So again, these are just my personal thresholds for my optimum variables of going out for aurora. So obviously we're going to need some clear skies. You're going to need a preceding solar event, whether it's a coronal mass ejection or a high-speed coronal stream a few days before. So we'll typically get a heads up for that, and then we'll know that 2 to 3, 4 days from now there's going to be aurora, depending on how fast that stream arrives. Ideally, you want a new moon. If there's too much moonlight, it could wash out the aurora, and it'll just be really faint and weak and hard to see. Having said that, having a bit of moonlight is really good because it lights up some of your foreground subjects. Make sure you have a plan of where you're going. Tell somebody if you're going out alone. I like to see at least a KP4 or above, because that's where it's moving off of that, just a band on the horizon, and you're starting to see some pillars and some more beautiful structure to it. Again, a hemispheric power of 40 or above, and then a solar wind of 500 or above, and then a BT, which relates to the magneticity as well, of +5, but BZ -5 or lesser, or greater, I should say. So the lower the number, the lower the negative number for BZ, the better. All right, so let's talk some gear. So pretty much any entry-level camera and kit lenses, or even smartphones, can capture the aurora. However, you're going to have a bit of an advantage if you do have a camera that handles noise well, because you're going to be shooting at a high ISO, and also some fast lenses with apertures at f2.8 or lower, because you want all that light coming in, shooting in low lighting conditions. You want as much light as you can coming in. You can shoot aurora at f4, but typically you're going to have to do a much longer exposure, probably somewhere around 20 to 30 seconds for it to pick up the aurora. And then some of your aurora shots the aurora might be a little bit blurry because it's constantly moving. So typically I like keeping my shutter speed anywhere between 3 and 10 seconds at the most. Also, a sturdy tripod, of course. You're shooting at night, so you're not going to be doing any handheld photography. A remote trigger would be a great asset as well. So that way you're not actually touching the camera, and you're just firing it off with a remote trigger. And then don't use any filters for night photography. So if you do have any like a UV filter or polarizer on your lens that you keep on there most of the time, I would take that off, because what'll happen is you might get some weird artifacts on some of your night images if you're using like, say, a UV filter or something. Some of these, you might get some of these things called Newton rings. And what Newton rings is, it's just these rings that kind of show up in your night images. And that's just because there might be a UV filter or polarizer on there that's creating some weird artifacts. Having some extra batteries are great, especially on those colder nights. Batteries die pretty quickly. It's good to keep them in your pocket. Remember to dress warm, of course. You're going to be standing around in a fixed position for quite a while. So even in the summer, it can get a little bit chilly at night. So just be prepared to, have a little bit extra clothes to kind of bundle up a little bit if you need to. Right. So settings. So settings for the Aurora can be all over the place. There's different strengths to the Aurora. You can have an amazing show and you'd be shooting at a faster shutter speed. So it really depends on the strength and speed of the Aurora, whether there's moonlight or not, and then other factors as well. So typically you want to shoot as wide open as your aperture as you can. So f2.8, or maybe you've got an f1.8 lens, something like that. And then you want to use full manual settings for Aurora. So manual focus is a must. Your camera is going to really struggle to focus if you've got it on autofocus at night, especially if there's nothing for it to focus on. But if you're having trouble with manual focus at night, you can try a few different things. So one technique is going into your live view on the back of your camera screen, and then zooming in with your live view and focusing on a star, and then just rotating your focus ring until that comes in nice and tack sharp. You can also use the moon or even a street light if there's one nearby. And another handy little tip that I find too is, if you're in the middle of nowhere and there's nothing like that, and you're having trouble trying to focus in on a star or something, just use a license plate from your vehicle. So if you just shine a light on your license plate, maybe just put a headlamp or a flashlight next to it, walk back probably about a good 30 to 50 feet, and then just focus in on the license plate. You should see your numbers and letters, and then just adjust your focus ring to fine tune everything so that it's in focus. And that should typically give you infinity focus as well for the night sky. And yeah, if you are running into situations where you're using a really high ISO, you can always fix that a little bit later with some programs like Topaz Denoise, or even just in Lightroom. You can apply a little bit of noise reduction there as well. So yeah, at first I really struggled with focusing in the dark, but ultimately using a bright point such as the moon or a street light, or even just zooming in on something in the distance, like a farm, lights from a farm or something, and that'll really usually solve that issue. Oh, I'm sorry, I'll just go back there. So just to for this one here, this particular shot, I used a shutter speed of 3 seconds. My aperture is at f2.0. I was using a Nikon 1.8 20 millimeter prime lens for this shot. My ISO was at 1600 and my white balance was on auto. And then for the metering, I just leave it on matrix, or I think it's called evaluative on Canon. So and that'll just make sure it's metering for the whole scene and not just part of the scene. And the reason I leave my white balance at auto, even though in post I'll usually set it to about 3,500 to 4,000 kelvins. I do this because if I set it in camera, I'll always usually forget to take it off that, and then the next day I'm going out and shooting landscapes, or maybe I'm going out and photographing birds or something, and everything's coming up blue because I've set the white balance down to such a cooler temperature. So now I just kind of leave everything on my white balance on auto for everything. So easy enough to adjust it in post in Lightroom or something like that. Right. So where should you go to photograph the aurora? So obviously a rule of thumb is to get away from the lights of the cities and towns. So find a dark area and just let your eyes adjust to the darkness over a period of about 20 to 30 minutes. So typically, don't even look at your phone until your eyes can adjust and get that, sense of darkness. So quiet roads are good, but obviously avoid private properties. You don't want to be trespassing, especially with so much rural crime going on. You might get yourself into trouble or worse. So typically places like national parks, provincial parks, natural areas, places where, you're pretty much allowed to be anytime. Um, and then just anywhere with a clear view of the horizon. You don't want to be in a place where you're just looking up and there's a whole bunch of trees there, because it might just block your view of the aurora if it's not that high in the sky. And then of course be careful of any wild animal encounters, even though they're pretty rare. And even people out looking to take advantage of you. So again, just use your common sense for safety. Tell someone where you're going. Better yet, go out with a friend or two, and it'll be a lot more fun. Cold weather shooting. So it's a good idea to keep your batteries in a pocket close to your body for warmth. They won't die quite as fast. When it's extremely cold, I'll use just a large Ziploc bag with like a desiccant pack in there, just to allow your camera to slowly warm up and avoid getting a lot of moisture in it. And then yeah, just make a plan and tell people where you're going. Always get permission if you're going on private property. If you can set up a deal with a farmer that's got an old barn and maybe trade some prints or something for photographing there, then that's always a great deal for both sides. So I'm just going to show you a comparison here between which really makes latitude important. So this is a typical KP3 aurora conditions here in central Alberta. This was in the Camrose area. So we're at 52 degrees north latitude. And this was actually, if you really look closely, you can see Comet Neowise here. This was in July of 2020 when we had the comet visiting for about a month or so. So that's a KP3 aurora condition. So you can see it's just kind of a band on the horizon, starting to see a little bit of pillars coming up from that band. So it's a decent display, but it's nothing crazy yet where it's overhead. Now, if we go to that same conditions up in Yellowknife, it's actually in Hay River. So this is just a KP3 event up there, but because they're so much further north at 61 degrees, then the oval that's passing over with all those particles in it is just pretty much almost overhead, and you're not looking, to it distantly in the horizon in the north. And here's a slide of both of those compared to each other. So obviously not the same night, it's not the exact same conditions, but it's pretty close to the same conditions. So just an idea of how much difference latitude can make when it comes to the northern lights. Okay, and here's just a few more up in the Northwest Territories. So you can just get some stunning shows up there, and it's almost a guarantee, especially if you go. So you don't want to go from April to August because it's too light up there. You won't see anything at night. But I love going up there in September because the lakes haven't frozen up yet. So you get these beautiful reflections and these beautiful displays right around the fall equinox is a great time, and I'll get into a little bit later, why it's so good around the equinoxes. And just a few more here from Yellowknife, the Yellowknife area. And just trying to use different foregrounds. There was a car going by in that third image there, so just adding a little bit of light trails in there, just for some added interest. So yeah, there's a place up in Yellowknife. If any of you been up there, you know it, but it's called the Ingram Trail, and it's about a 70-kilometer dead end. It's a dead end highway, but it goes 70 kilometers in each direction from Yellowknife and back. And it's a great place for going out and aurora viewing. The further you get away from, the further along you get into it, the less people you'll see. And it's just a great place for tons of places to stop, tons of little lakes, tons of campgrounds, little provincial parks stop off at. There's some waterfalls along there. So I highly recommend going up to Yellowknife if you get a chance, if you really want to see an awesome aurora display. And then just a few more here. These were in Hay River. The south part of the Great Slave Lake in Hay River has a lot of driftwood logs on it. So that third image there, I used those as a foreground. And then someone had stacked some up as like a little teepee. So use that as well as some foreground interest. So just going up to the Northwest Territories is worth it if you ever really want to get like some great aurora. You can get some awesome aurora shows here in Alberta, of course. But if you want to go up, it's almost like I said, it's almost a guarantee getting some really good aurora up there. And then again, just a couple more images here. So open water, again, is just my favorite. The symmetry of the reflections, it's just mind blowing being out there when you get a display where it's covering up the whole night sky like this. And one more here. So you get tons of different shapes and patterns. The aurora is always changing to different patterns and displays in the sky, strengths and weaknesses. It comes and goes. So it's great just sitting alongside the lake and watching it, the reflection dance in the water. So I've tried to simulate what you would see here with the naked eye. So because humans' vision is not ideally suited for nighttime, we almost see in kind of a black and white. So this makes greens appear as kind of a dullish gray typically in all but the biggest aurora displays. So with a longer exposure from a camera, and our camera can pick up more light than our eyes can, it'll show you a much better detail of the aurora. So camera settings can also play a role too. So just having another good thing to do is having your LCD. So your LCD on the back of your camera will typically always be set to a little bit brighter than the actual image will be. So one of the first things I do with my LCD when I'm shooting at night is I'll just take the power of the LCD screen, and I'll just set it down a few notches, just so it's showing more of an accurate representation of what you're actually picking up. And then, of course, using your histogram as well. So typically you're going to be exposing more to that left side with the darks and the shadows, but you don't want it completely all the way over there, and try and bounce it a little bit more over to the right side. All right, so this is what I was talking about a little bit earlier with the Earth's seasonal axis tilt. So we of course have the summer and the winter solstice, and the fall and the spring equinox. So these are the best times to see the aurora, as this seasonal axis tilt kind of lets in a little bit more of that solar wind and those particles for whatever reason, just the way the Earth is tilting at that time of year. But it just seems that there's some supercharged shows around the equinoxes, especially in the spring and fall. So I don't know if any of you guys got out for the recent display on March 23rd, but that was typically kind of supersized in a way from this Earth seasonal axis tilt and being so close to the spring equinox. And then even I shot this from my living room in South Edmonton. So if you get a really strong display, you can actually even see it right over the city lights, if it's a really, really good display. And here's one just over an abandoned house. So got permission from a farmer to use this. And then, I was out with a friend or two, and we just placed some lights inside for some added effect with the composition, just to enhance things a little bit and create a little bit more interest. So yeah, so abandoned buildings can be a great. So if you know someone that has an abandoned building on their property, I would say, try and get in there and trade them some prints or something, or see if they'll let you shoot there. Here's another one, an abandoned homestead. And sometimes these will just be along the side of the highway as well. So you don't really need permission. You can shoot right from the highway or right from the road. Just make sure you're parked safely at night, of course, pulled off a bit, so you're not in the way of any traffic, and watch for vehicles. And then just a few more. These are all from up in the Northwest Territories as well. So we had a teepee this one night that was at a place called Blatchford Lake Lodge. And there's a little waterfalls there. It's called Cameron Falls. So had some really nice pillars over the falls that night. And it was just a beautiful, beautiful place to hang out for a couple of hours. And again, the reflections are just incredible. And a few more images here. So just looking for different things to add to your image. So it's not just, a green in the sky. So again, some reflections out at Elk Island Park here. And I called that middle one Cowrora. So, I jokingly said we were out shooting until the cows came home. It was kind of funny, the story behind that one. I was shooting actually the other direction. It was a really strong display that night. And I heard all this trampling behind me off into the little field behind me. And, I turned around with my headlamp to see what it was. And there was all these eyes glowing at me. And it was really freaky, but it turned out it was just a bunch of cows, and they were just as curious of me as I was of them. So yeah, you can always get some fun stories out shooting the aurora as well. And that third picture there, it's called Ribbons and Meteors. There's a little meteor caught in the far left or the far right side of the frame there. So that just the way the aurora appeared that night, it was just unique, and one of my favorite displays that I've ever seen. And here's a few more. So this was that November 4th, 2021 show. It started off fairly mediocre. I was out with a couple people, and they called it a night around midnight. I persevered because the data was looking great, and I just felt it was going to explode at any time. And sure enough, probably at about just before 1 o'clock in the morning, close between 1 and 2 in the morning, it just went nuts for a while. And I had actually packed up, and I was ready to go home at 4 o'clock. I was exhausted. I was tired and cold and hungry. I just wanted to get home. And I got to the parking lot, and these beautiful red colors started appearing, and everything went nuts for probably about 15 or 20 minutes. So I was just trying to compose from the parking lot, whatever I could. So just using some trees in that first image there, and then the image on the far right. I call that one the Rainbow Bridge. It was just these beautiful colors. So that's looking straight up directly into the sky, pointing my camera pretty much straight up. And then the middle one there was a little bit earlier in the evening. So the lake had just frozen over. So there was this island out there in the middle of it, and just capturing it, dancing over there. So these three were all in the same night. So you can get some, really unique images just in the same night, just depending on what the aurora is doing, and how the data kind of comes and goes in waves. All right, so this is Aurora Corona. So what is Aurora Corona? Corona is Latin for crown, and the Corona perspective, just like in the last image I was showing you, is basically just pointing your camera straight up into the sky. So this would be like directly overhead. So it's typically stretching from one horizon to another, and this you'll probably need at least a KP5, KP6 in Central Alberta to at least to see this. So while it appears like it's directly over, it's just perspective from that oval going across. And then here's another one from the Corona perspective. So you can get some really nice abstract images, just pointing your camera straight up into the sky, and it's just dancing around, and it's moving really quick, but just, some nice quick exposures. And then this other one here is one of my favorites of all time. So that was that night where the Reds came out for about 15 or 20 minutes in the morning, and it was just just vibrant and beautiful, and it was dancing, and it was just like the spectrum moving across the sky. Okay, so here's a panorama. So I don't really do a whole lot of panoramas, and for me, they're nothing too fancy. I'm basically just moving my tripod as slowly as I can, taking shots, overlapping them by about probably at least 50% frame to the next frame. So it's not perfect. As I tried to shoot this really quickly, the aurora was obviously moving, is obviously moving all the time. So it can be tricky to shoot multiple images and have them stitched together. So I just flipped my camera vertical here, and then I took 11 2-second exposures going across, overlapping them by 50%, and stitched them together using the Lightroom tool. So yeah, for night photography panos, I would try to at least overlap each frame by about 50% going into the previous frame. And full moon aurora. So earlier I talked about, ideally you want a new moon where there's no moonlight, but if you have a great display and there's a full moon, don't let it stop you from going out to shoot it. So there's obviously pros and cons to moonlit nights. So the pros, it's much easier to see. You don't really even need a headlamp. The foreground's already lit up for you, so you don't need to use any artificial lighting for lighting up some of your subjects. And then the cons, of course, the aurora won't be quite as strong because it will be washed out a little bit by the moonlight. But if you have a really strong display, then you are going to get into, being able to see it no problem. And you also have to watch for moon shadows too. So just like if you're shooting in the daytime and the sun is right behind you, you have to kind of watch of your shadow not getting into the frame. And the same thing applies at night with the moon. Okay, and then here's another one during full moon, and it's just aurora over a rusted old car out in the field. Um, just just another amazing night. I can tell you this one was back in 2017. We had a really good show towards the end of May, and yeah, it was just phenomenal. Some of the displays we got that night. And just another one with a full moon here. So this is just outside of Edmonton. This little shack has unfortunately actually been torn down now. It's long gone, but when it was out there, it was a nice little go-to place to meet up with some other aurora chasers, and made for a nice little foreground subject. And a few more here from the winter. So I like how the snow kind of adds a nice little bit of contrast as well to the green in the sky and the white on the ground. So getting out in the winter for full moon aurora is can be quite fun and cold. All right, so Steve, I don't know if any of you guys have heard of Steve. You probably have. Steve's a relatively new phenomenon. It was actually discovered here in Alberta by citizen scientists. It was named by Chris Ratzlaff, who is the founder of the Alberta Aurora Chasers group on Facebook, which is an excellent resource, by the way. Highly recommend joining that group if you're interested in Aurora. How it got its name is they didn't really know what to call it. So it comes from the movie Over the Hedge, and then the plot in the story in the movie was all these creatures of the forest. All of a sudden, humans were doing housing developments on close to the edge of their forest, and there was this big hedge there this one day. So they didn't know what to call it, so they called it Steve. So that's how they came up with the name of this as well. They just called it Steve. And ultimately, once they got some scientists behind there and did some more research on it, they ultimately came up with the acronym Strong Thermal Emission Velocity Enhancement. So kind of fun. It typically only comes out before a pretty decent aurora show, and it's usually seen in the southern part of the sky. And it's a 25-kilometer wide ribbon of hot plasma, and it's 450 kilometers up in the atmosphere. So just a little bit about night sky photography etiquette. So, you want to watch your light, be cognizant of your surroundings. Use use a red light if you can. Red light is much easier on your eyes. It'll help you see better in the dark. Some headlamps and flashlights have a red light setting. Use a headlamp sparingly if you can. If you're out in your vehicle, turn your headlights off when other photographers are shooting. There's a neat little trick on most vehicles to turn off, most of the newer vehicles, to turn off your headlights. Simply turn your car. Trying to think of the best way to do it. It's turn your emergency brake on, turn your car off, then turn your lights on, and then start your car again. And usually the lights will not come on. So yeah, and if you're out shooting with a group, just ask, is it okay if I turn my light on? That way your light isn't showing up in other people's shots. Okay, so getting into some helpful sites and apps. So Space Weather Live is the app I was talking about before and went through the data on. So that's my ultimate go-to app. It's either you can use it as a website or an app that's free on the Google Play and the Apple Store. Highly recommend it. It's like I said, it's the best real-time data source for Aurora data. Yeah, and that's it's almost a no-brainer for that app. It's such a good tool. And the NOAA, which is the National Oceanic and Atmospheric Administration, has an email service, so you can sign up for their email. Just it's a free subscription. You'll receive a 3-day aurora prediction forecast. It's telling you what the KP index is forecast to be. So I actually just grabbed this slide today. So it'll tell you the April 12th, 13th, and 14th, and going through the universal time, which is 6 hours ahead of us here in mountain time. So that's something to be wary of as well. 7 in the winter when we're in daylight savings time. And yeah, it'll just go through the suggested KP index there. So just looking at that, we're anywhere from a 1 to about a 3 over the next 3 days. So nothing too significant, as there hasn't really been any coronal mass ejections or solar streams headed our way. Another really handy app, which is free as well, is called Astrospheric. So obviously finding clear skies is probably the #1 thing when you're going out to shoot aurora. If it's cloudy and overcast, then no matter what the aurora is doing, you're not going to see anything. So just trying to find some clear sky. This is a great app for that because the top layer, which is that, it's hard to see here in this little screenshot, but the very top line is the seeing capability. So having no clouds, that the bluer that time frame is, the less clouds there's going to be. Once you get into gray and white colors, then it's going to be cloudy. So, and it gives you a map, so it's great to find. It's going to be cloudy in Red Deer, but if I just go, a bit east over to say Oyen or somewhere, it's going to be clear there. So that might be a good place to go tonight. So it predicts the cloud cover for the next several days. I think it's got 3 or 4 days of immediate data with full data. And then down at the bottom, there's an extended cloud forecast for the next week, which is, hit and miss, really. It's just a kind of a more of a long-term forecast. And some of the recent updates, they've added the KP index directly into there, so you'll know what it is. And as well, the moon phase, right? So that's also important as well. And again, this is a free app on the Google Play and Apple Store, so almost another no-brainer, really, to add to your photography arsenal. And it's great for even just finding, I use it too for predicting, how to find good sunsets and sunrises, because typically you want about a 30 to 50% cloud cover. So you'll that sun will let some gaps through and light up those clouds nicely. So it's a great all-around app for photography. And then one other cloud forecasting app, which you can use as a comparison between Astrospheric, and this one is called Windy. And that will also show you the cloud patterns. And I think it comes from different models. So that way you'll be able to compare different cloud models and have 2 sources of info rather than just relying on one. Okay, and that brings to the end. I think I went through that fairly fast. So I'm sure you guys will have some questions. if you are looking to find me on social media, there's my social media links there and my website. But yeah, I'm ready to start taking any questions that you guys have.
All right, for questions, if anybody's got any questions, I'll bring the microphone around so then Mark can hear you. Questions and okay, you guys fine.
Do you use a wide angle lens or a normal lens?
Sorry, just to confirm, that was do I use a wide angle lens or a normal lens? Yeah. So typically the wider the better. So if you're shooting on a full frame camera, you probably want 14 millimeter would be, maybe like a 14 to 24 would be great. Having said that, though, I do a lot of my aurora photography too with just a 20 millimeter prime lens. So typically anywhere in that 14 to 24 millimeter range. So whether you have a 16 millimeter lens or even like something really wide, like a 12 millimeter, but typically the wider the better for aurora.
Thank you.
You're welcome.
Anyone else? Oh, back at the back of the room here.
They usually just travel in a certain direction or that's all.
Sorry, that one broke up a little bit there. I didn't quite hear that.
Yeah, I don't think it's the light on. Got the light. Oh, but we're getting too far from now. Okay, let's go to the front of the room apparently.
Oh, okay.
The front of the room because the microphone doesn't have that range. There we go.
So my question was, do they travel in any certain direction?
The northern lights, like as they're coming towards the earth, or just typically in the sky themselves from as we view them looking up?
As we're looking up, like, do they go north to south or?
You'll typically, so in the early part of the evening, you'll probably see them appearing in the northeastern part of the sky. So that's when that oval is just coming into the range. So the oval will typically go clockwise around the earth. So it'll start typically, let's say it starts in Scandinavia, it'll go over towards Iceland, Greenland, then into Eastern Canada, and then Central Canada, and then here Alberta, and then Alaska, Russia, and so on. So it's constantly that oval, as it basically ties into darkness as well. So it's constantly coming, heading west, I guess you could say. As far as looking directly up and seeing what directions the aurora goes, it could be anywhere. You could even see them in the south during a really strong display, but typically north is your best bet. That's where you'll see them to begin with, and then from there the patterns could really be anywhere.
All right, thank you. Any other questions? Anybody want to take the long walk up to the front? Carmen, we're gonna see if it.
My question is, does the solar wind speed directly affect the movement and how quickly the aurora moves?
It does in a way, yeah, for sure. So the solar wind speed is basically how fast it's traveling from the sun to our earth. So the higher number, the better, because what it's doing is the faster it travels, the more particles it's going to bring in. And yeah, the science behind it is still a little bit kind of up in the air, but from what I understand, the higher the solar wind speed, it's going to create a bigger display for us based on just having more particles in the atmosphere.
Okay, I actually have a question for you as well.
Sure.
Your new moon versus full moon.
Yeah.
What do you adjust your shutter speed on that? Because you probably wouldn't use as long a shutter speed, right?
Exactly. Yeah. So probably affect a couple things for sure. So both your shutter speed, so you're going to have a lot shorter shots with a full moon because everything's kind of more illuminated. So probably for a full moon, you're probably going to be anywhere from 2 to maybe upwards of 10 seconds, depending on all the other factors going on. And then with a new moon where it's pretty dark, you're probably going to be looking at anywhere from 10 seconds up to maybe 20 25 seconds, depending on conditions. And then of course your ISO can come into play as well, right? So where it's a full moon, I'll probably keep my ISO down a bit lower to have less noise going into my shots. Probably my ISO can be as little as 200 or 400, and going up to about 800 during a full moon. And then during a new moon, I might really push it to like 1600, 3200. In some cases, maybe 6400, if I really think I can clean that noise up in post-production.
All right. Is there any other questions? Anybody? No, looks like, Carmen's got another one.
Sure. Yeah.
How do you edit your Aurora photos?
Yeah, so that's a good question. I don't really edit them a lot. So I'll bring them into Lightroom, they're a standard raw image. So I'll, maybe increase the highlights and shadows, add a little bit of contrast. But as far as, I'll pretty much leave the colors typically the same. I won't add any vibrance or saturation or anything like that. And yeah, that's pretty much it. They won't really touch Photoshop or any other editing programs, just because, they're beautiful as they are. And yeah, it really depends if I've maybe included a foreground, like maybe a barn or something like that, lit up with a little bit of low level lighting or something. So that might play into a little bit more, but typically the edits are fairly minimal for Aurora, and just with my perspective anyway.
All right. Anything? No? Okay, well, that looks like it. We thank you a lot for this, Mark. It was a great presentation. I know personally I'd love to get some great shots like that, but I have two things holding me back: is I can't stand winter, and I'm usually in bed by 9 or 9:30. So
yeah, for sure. So yeah, and that kind of works against you both ways, because when it's finally nice in summer, it doesn't even get dark until about 10 o'clock, right? So but what I would recommend is, if like I said, if you ever get a chance to go up to Yellowknife, that's almost a guarantee for Aurora. So and you can get them much earlier in the evening up there, if you go in September when it's getting it's starting to get darker earlier, or especially in the dead of winter. Of course, it's going to be really cold up there, of course, but yeah, I would recommend a trip up to Yellowknife if you really for sure want to get some really good Aurora.
excellent. Well, again, thanks, and thanks for the short notice filling in for us. Before you go, did you want to plug your lessons on your Lightroom that you're doing? We've got it on,
for sure.
on our website, but if you want to plug it tonight.
Oh, thank you very much for that. So if anyone wants to, I do have them on my website. So typically right now I'm just doing them on Sundays and Mondays, at different time slots. And some, not every Sunday, because some Sundays I can't, but if those times don't work for someone and you're looking for a different day, I could probably make that work. So it's basically, I've geared them more towards Lightroom training, and just going over all the tools you can use for editing photos in Lightroom. They're typically 90-minute sessions, and repeat sessions are welcome if you want to kind of go over and do some kind of mentorship program. And they don't actually have to be for Lightroom. They could be for pretty much anything you want to go over photography related. Whether you want to go over some images and see if there's any room for improvement or anything like that, or things that I would do differently. But yeah, they're pretty they're casual, laid back, basically a 90-minute coffee chat, going through some different things, and hopefully some takeaways, some helpful tips.
All right, thank you. And again, that information is on Mark's website, and you can also find it on the homepage of our CAPS website as well.
Awesome.
Okay, thanks again, Mark.
Thank you guys very much for having me, and I really appreciate it. And maybe next time down the road in the future, I can be there in person to do another presentation, down the road at some point. So thanks everyone for tuning in.
Okay, thank you.
Have a good evening.